Now we would like to solve this initial value problem. So first thing we notice is that this problem, or rather in this problem, that it is not a separable equation. So what we may try to do is try to see if it can be a linear equation. Now of course we have a y square here, so on here we don't have a function of x, but noting that 1 over y square is the derivative of negative 1 over y, we may do this, divide by y square. So we'll get a y square here and a 1 over y here, and this y square disappears. Okay, and of course we will divide by this x. Okay, so in order to set it up like that, so let's divide the equation by x. Okay, and when we do that, what we get the following, that we have this 1 plus x over x here, and this becomes a 1. So now we can substitute 1 over y equals, we may say u, or whichever other letter you want. Okay, so when we, or yeah, let's substitute negative 1 over y, won't have really mattered much. So when we do that, then when we are relating the differentials, the derivative of negative 1 over y is 1 over y square. Then we have dy equals du, or rather we may say 1 over y dy dx is du dx. Okay, so with this substitution, our equation becomes, or rather this equation becomes du dx, okay, du dx minus 1 plus x over x times u equals 1. Now we can find the integrating factor, that is that will be obtained by taking the exponential of the integral of this quantity. So first let's go ahead and write the integral of this quantity. Okay, so we have this here. Okay, so when we can pull the negative sign out, sorry, so let's pull the negative sign out, and then we get this here, 1 plus x over x dx. So in this case I think dividing will be a good strategy, because so we have a rational function there, so we are dividing it, so we get 1 over x plus x over x will be a 1, and then the value becomes what? Negative. We should have a natural log of absolute value of x, but we are looking in the vicinity of 2, 1, so we may assume that our x is positive. All right, so let's just leave it as x. Okay, and then we get negative x. So what this becomes is actually negative ln of x plus x. We may write it like, or it's okay, we may say plus x here, nothing wrong. So who is my integrating factor? My integrating factor is, sorry, e to the power e to the power negative, excuse me, ln x plus x, which is e to the power negative ln x plus e to the power, no, sorry, actually times e to the power x. All right, you can see I'm making this video too late in the evening. Okay, so here we go. So we have negative 1 here. So what that is going to give us is e to the ln of x to the negative 1. Now e exponential and natural log are inverses of each other, so this comes out to be the integrating factor. Okay, so when we go ahead and write our solution, then what will happen is our solution will be this quantity times u equals so equals the antiderivative of the integrating factor times what we had on the right hand side. So we have 1 here, so we get a dx here. Now the problem is this antiderivative doesn't look like that I'll be able to handle it at this time, so let me see if I have to leave it like this or I made a mistake. So 1 sec. Okay, so yes, it's only me because we are not doing it interactively. Okay, so we have, oh, here we are, see this here, we took negative 1 over y as u, and when we transform this equation from here to here, this should have been a plus sign, which I took as negative. So all these negative signs go away. I'm so sorry about this mistake. Okay, all right, so here we are. So this goes away, and hope I'm not causing confusion instead of explanation. Okay, and I shall post a transcript of this on the website, so you shall see the corrected version. So that's x to the ex. All right, and now we have to integrate this portion here, which is going to be an easy integration by parts integral. Remember this, that you had you may say, since we already used up u here, so I may say, let me just take quickly some other symbols. Say w dz equals wz minus integral z dw, right? That's what integral by parts is. So for dz, if we took e to the x dx, then who z will be? That will be simply e to the x, and w, of course, we are taking as x, so we have x e to the power x as wz. All right, minus, then we have who is my z, e to the x. All right, so I get e to the x, and w is dx, so dw would be, w is x, so dw is dx, so this becomes x e to the power x minus e to the power x, and we may put a constant at the end that we have to determine. So what is our solution then? I'm going to copy this again so that I don't repeat the earlier mistake. So we have what do we have then? We got this here, equal to this. Now if we put our or write our u back, who was our u? U was -1 over y, right? So we have -1 over y here, right? Okay, or in other words, we can do what? Write it as y equals, okay, I'll just put a negative sign here, x e to the x divided by this entire quantity. Okay, and since we had, what was the initial condition? That was y2 equals 1. So when x is 2, y is how much? 1. So if we use that condition, so y is 1, I got a 2, I got a 2 here also, then I have a 2 here and a 2 here and a 2 here. So what do we get? We simply get, so here this 2e square minus e square will be simply e square, and we can solve for c. So just a second. Okay, so if we solve for c, the solution is e to the -3 times e square. All right, so here we go. So our solution is right here, -3 e square. I'm just going to graph it because you could see that I was getting a little tired. So let's see. Yeah, it does pass through what? It does pass through it passed through x equals 2, y equals 1. So looks like we have a correct answer.